All right, so AlNO3 ends up being AlNO3 with the parentheses 3. Okay, let me get my notes real quick. Okay, understanding that this is on part of your problems on the thing. All right, so AlNO3. And this is going to be the solution of AlNO3, 3. So you go back to the original equation and you write it out. You have sodium phosphate, Na3PO4, mixes with aluminum nitrate. Okay, now, before you go on, you need to figure out whether it's soluble or insoluble. So tell me, sodium phosphate, is it soluble or insoluble?
How would you know?
It's insoluble. It's insoluble? Sodium, with the exception of group 1. Okay, so phosphate is normally not soluble unless it's bonding with group 1A. So this guy, what it means to be soluble is that before it goes onto the reaction, it's going to split into Na plus PO4 3 minus. Now, is nitrate and aluminum soluble? Check the solubility rule. It is soluble. So that means, again, this is going to split. So this is going to become Al plus 3 and NO3 minus 1, right? Now we can predict the reaction. Let's group the ones that are going to bond. So that's negative. That's positive. So these guys are going to go together. This is positive, that's negative. So these are going to write. So now, go ahead and put them together. So when you put them together, you have AlPO4 and sodium nitrate. Now let's check. Is this soluble?
Yes.
It is soluble. Insoluble or soluble? Insoluble, because that's not group 1A, so that stays. Nitrate and sodium nitrate, soluble or insoluble? So that means this is going to fall apart to form NO3 minus, right? So if I were to rewrite this equation, on the reactant side, I have Na plus PO4 3 minus plus Al NO3 yielding AlPO4 together because they don't dissolve, right? You have AlPO4, but this is soluble, so it is going to fall apart. So you have Na and NO3. Hold on a second. Let me finish this problem. When it's soluble, it means separate. So, I'm going to show you. So this is on the product side. That's the reactant side. What are the common things on the left and right? So this crosses out. So the final equation that you write is only Al3 plus PO4 3 minus on the reactant side yields AlPO4. This is known as your net ionic equation. Now, the ones that you crossed out are known as spectator ions. So, let's do the next problem together. Okay, so number 2, you have silver nitrate, sodium chloride. Okay, now, first things first, if you don't know your charges of polyatomic ion, you can't do this. So if you don't know it, go back and memorize all of them, right? So silver is a transition metal that always have a charge of positive 1. Nitrate, you have -1, positive, negative. Now, you look at your solubility rule. You realize that this is soluble, that's soluble. That means before it goes on to predict the reaction to the right, you have to separate them into respective ions. So you have sodium ion and chloride ion and nitrate ion and silver ion. Okay, positive and negative, and positive and negative. So when you do that, you get AgCl plus NaNO3. Now, AgCl, you realize that soluble or insoluble?
Insoluble.
So this stays together. NaNO3, soluble or insoluble?
Soluble.
So that means it falls apart. So you can rewrite this as Na plus
Did you get it right, Barry?
and NO3 minus. Now, let's look at this. Everyone else got it, Brandy. Good job. Alright, so we need to cross out our what? What is it called?
NO3.
Spectator ions. Okay, vocabulary is very important. So what are we crossing out? Spectator ions. So the things that are spectator ions are the ones that are on the left-hand side that are exactly the same as right. So you have sodium that's crossing out, nitrate that's crossing out. So your net ionic equation is Ag plus Cl minus yielding AgCl. That is your final answer. And this is insoluble, so what's the state? Solid. And this is all aqueous, right? Aqueous, it's in the melted. Okay, go ahead and do number 3. Okay, so let's do number 3. So copper 2 sulfate. You write your copper and sulfate, and you say the sulfate has a negative 2 charge, but except that copper also has 2 plus charge. So they can just come together, form a regular compound without anything, so it's just copper sulfate together. Now, it's going to be added to barium hydroxide. Barium, you know, has positive 2 charge, so you need parentheses around hydroxide, and you need 2 of those, because each hydroxide is negative 1. Now, here's the thing. I see a lot of people writing these, like, charges there. That's incorrect, right? So, even though you're working out the charges and doing this business, after you're done, you should delete it. You should erase it. So, people who are grading your test doesn't think that you don't know how to write a formula compound. Okay, now, it's going to give you something, but before you go on, you need to check if it's soluble or insoluble. It happens so that they are all soluble on this side. That gives you Cu with the 2 plus charge, because it's copper 2 over here. Sulfate, you know, has 2 minus charge. Now, this, when it breaks down, you still have to keep the number of hydroxide ions the same. So when that happens, you have Ba plus 2 with 2 hydroxide ions. When you do that, positive and negative, negative and positive. So you have copper bonding with hydroxide and barium bonding with sulfate. You rewrite it, you get CuOH2 and BaSO4. Again, charge is balanced. However, let's check the solubility.
They're both insoluble.
Hydroxide is insoluble except with group 2A calcium down. Barium happens to be one of them. So this is soluble, so it breaks apart. So you have CH2+. Oh, my bad. Barium.
Right.
I meant to write it for barium. So when you do that, you get Ba2+.
No, that's insoluble.
That is insoluble. Oh, they're both insoluble. I wrote it wrong. Ca. That's what you're saying. Oh, okay, got it. My bad. Guys, let me correct it, okay? My apologies. On my thing, it says copper or calcium. Okay. So is calcium soluble or insoluble?
Insoluble. Copper.
Oh, Cu. Copper. Is copper insoluble or soluble? Insoluble. So this is the net ionic equation, right? Okay, so you guys on the, okay, that's fine.
What about the outside, the septic? Oh, you mean,
This is the answer.
spectator shit. Yeah, what about those?
Okay, listen. Is there anything canceling out?
Yeah, it's insoluble. So you don't have the whole thing, it's insoluble. You don't have
There you go. Because it doesn't cancel anything out, you don't have any spectator ions, so they're all participating. Okay, Gabby, what's up? Yeah, because there's 2 hydroxide over here. So you need to be balanced. There are two hydroxide. Look at the parentheses. I'm just balancing equations.